The Mind's Eye with BJ Turnoff. It's available on iTunes, Pandora, Amazon, and all major platforms. Appreciate you listening. Appreciate you subscribing. Feed your head, engage your brain, and enter the Mind's Eye, the intersection between history and mystery, the center of science and the strange, and your source for the subliminal to the criminal. I'm DJ BJ Turnoff, host of this auditorium of audacity. On a couple past episodes, I've talked about a couple events in my life that have been supremely strange and really stopped me dead in my track and made me think, that is just so crazy. No way that could just happen. The other day, I was reading an article of that exact thing when there was I believe it was a New York-based musician. She went overseas and just went to this random cafe wherever she was in, and the waiter who ended up serving her literally had the same exact tattoo she had, but in mirror form. 2 on their fingers and one on big one on their forearms. So actually the same exact tattoos, the same exact location, same exact style, just mirror images of each other. One was a man and the other one was a female. I mean, the chances of that happening are just so small, and stuff like that just makes you think what is going on here? Probability. I mean, your brain can't even really compute it. I mean, it's astonished, and then it just has to move on, or else it won't know what to do. That circumstance for people like entrepreneur Elon Musk, theoretical physicist Neil deGrasse Tyson, and famous sci-fi writer Philip K. Dick. That's like a perfect example of their beliefs that they think that we're living in some type of illusion, some computer-generated reality, and artificial simulation. Think like Matrix-type reality. And surprisingly, recently, a number of scientists, engineers, and professors, they have given what's been dubbed the simulation theory pretty serious consideration. Even philosophers and spiritualists are gravitating toward it because it is rooted in ancient religion. And this idea is just so out there that I really wanted to ground that idea of living inside a computer generation in as much reality as possible. That's why our guest for this edition is Rizwan Virk, renowned MIT computer scientist and Silicon Valley video game designer. He is also a best-selling author. His last 2 books, The Simulation Hypothesis and The Simulation Multiverse, we're going to go into that tonight. I really appreciated how he crossed technology and mysticism, so it really was an interesting read. You can learn a little bit more about both those books and Rizwan Virk on our website, themindseyemedia.com. And while you're there, you might just notice that we have over 120 plus free episodes. If you do go through those and you appreciate it and you enjoy it, I won't stop you from also hitting the donate button at the top of the website. And no matter how big or small, everyone who donates, you are going to get something in return, whether it's a free book or a free unaired show or one that's not in the archives. But of course, the more that you give, the more that you're going to get in return. And I really do appreciate for those who do donate. Again, go to themindseyemedia.com. Let's welcome our guest for the evening, Rizwan Virk, entrepreneur, venture capitalist, and video game pioneer. Riz, thanks for the moment.
Thanks so much for having me on.
Talk a little bit about you. Like any video game character, you've had your own adventures. Tell me a little bit about your journey from video games to, I guess, really being a proponent of the simulation theory.
Yeah, sure. So, I'm a computer scientist by training and, built lots of different kinds of software and got involved in the video game industry about a decade ago now. And we had one of the very top games in the iTunes App Store when Apple first released mobile apps. It was called Tapfish, and we had something like 34 to 50 million downloads of that game. And then we ended up selling that to a big Japanese company, and then I became an investor and advisor to a bunch of different video game companies. So, and I went back to MIT and was helping run a program called Play Labs, where we helped students and alumni build video game startups and take their products to market. And it was around that time we were doing a lot of virtual reality and augmented reality that I ended up visiting one of the companies I was involved with, and they asked me if I wanted to put on a VR headset and play a virtual ping pong game. And I said, yeah, sure. And so I tried it. And what happened during the course of this table tennis game was that I forgot that I had a headset on. And it felt almost as if there was an actual ball that I was hitting with a real paddle that was hitting a table. And so it's not so much that the graphics were great, it was more that the responsiveness of the system fooled my brain into thinking that I was somewhere that I wasn't. And so much so that at the end of the game, I tried to put the paddle down on the table. And of course, there was no table, and the paddle was just my controller, which fell to the floor. And as I leaned against the table, I almost fell over. And that's really when I realized that, our immersiveness is getting pretty good. And I started to wonder, how long will it take us, meaning, technologists and scientists, to build something akin to the Matrix, which would be a full immersion, what I call the simulation point. So I came up with the stages of the road to the simulation point, which is 10 stages of technology. And, that kind of sent me down the rabbit hole that said, well, if we can get there within a certain period of time, is it possible we're already in a simulation? And then I did a lot of research into quantum physics and some of the mysteries there, as well as the world's religions and some of the mysteries there, and realized that the best explanation for all these things was that we were already inside a simulation. And that's what led me to write the first book, The Simulation Hypothesis. And of course, now I've just come out with the second book, The Simulated Multiverse.
Kind of show us your cards a little bit. What's your best evidence, that we're living in a simulation?
As I started to look into it, I realized that there were a lot of mysteries, within the world of both quantum physics and relativity that really didn't make sense, in a physical world. For example, the speed of light is the speed limit in the universe. And it turns out that you and I are also speaking today in a virtual environment, right? I'm not actually talking to you. I'm sending the bits over the wire using electromagnetic signals, which are traveling at the speed of light, and you are hearing a representation of my voice. And so, the more I looked into it, the more it became odd that we had this arbitrary limit to speed in a universe, and it just didn't make sense if it was a physical universe. But since the maximum speed of information flow is the same as the speed limit of the universe, that sort of led me down this path that perhaps we are actually living in an information-based reality. Then I started to look at the idea that space was pixelated, which means that there are discrete elements or pixels. And turns out there actually is a smallest amount, the Planck length, beyond which we can't measure. And it turns out that's very similar to how we create video games with pixels. And you can't really do anything at smaller than that pixel. That becomes the resolution of the world. But what really, clinched it for me was when I started to look at quantum indeterminacy, which is known as the observer effect. And, probably the best way to explain it, and you may have already talked about it on your show before, is to use the example of Schrodinger's cat. And this will tie to both, the simulation hypothesis and the multiverse idea, because there are two different interpretations of this basic phenomena, which started with the double slit experiment. And, it was so bizarre that Niels Bohr said, that anyone who thinks that it isn't ridiculous hasn't really understood it, right? And so Schrodinger, who was one of the founders of quantum mechanics, didn't like it. And so he came up with this, what he thought was a ridiculous example. He said, well, if there was this cat in a box and the cat has some radioactive material and some poison that gets set off by the radioactive material with a 50% chance after an hour, is the cat alive or dead? And what quantum mechanics was telling him was that the cat was both alive and dead until somebody observed or measured the phenomenon. And common sense tells us, well, the cat is either alive or dead. It can't be both. It's one or the other. We just don't know because we haven't looked in the box. But inside the box, there's only one reality. Turns out that's not what quantum mechanics is telling us. It's telling us that both realities exist. The cat is in superposition until there is a measurement done. And so the golden rule seems to be that only when something is observed or measured do we need to render it. And it turns out that's exactly how we make video games. right? When the reason I can be inside Fortnite or World of Warcraft or even Grand Theft Auto and see what my avatar is seeing is because my computer only needs to render that which is seen by the avatar. Now, that's not how video games used to be built. They used to be built by trying to render all the pixels. And turns out you can only, you can't make very sophisticated games. You can only make very simple games like that. But we've improved using optimization techniques and modeling. We've come up with this model that says only render that which is observed. And moreover, you're doing that from multiple perspectives. So anyway, those are some of the things that I came across that led me to wonder if this really makes sense that we're in a physical reality. And then it turns out there was a famous physicist named John Wheeler who worked, just down the road from down the hall from Einstein at Princeton, and who also worked with many of the other giants of quantum mechanics. And he said that at the beginning of the last century, in his lifetime, everyone thought that there was a thing called matter. It was made of particles. They were these hard objects. And then they said, well, no, it's really a field of probabilities. But by the end of his career, he came to realize that the only thing that distinguishes one particle from another is a set of answers to yes/no questions, right? And what is a set of answers to yes/no questions? It's actually information. That's what bits are, right? Every bit has a value of yes or no. So it's almost like when physicists try to find this thing called a physical world, they can't find it. The only thing they can find at the bottom is information. So Wheeler came up with a great phrase, which is called it from bit, which is anything that's an it, like this table or this chair. We think of these as solid its, right, as objects, but really they're just made up of bits of information. And so, that led me down this path that perhaps information is actually the most important thing. Those are some of the pieces of evidence that I think makes it so that we should take this idea a little more seriously, that we may be in an information-based reality that gets rendered when it's observed.
Personally, it really made me think, like, what moments in my life could I say, okay, this is kind of wonky. Is there something that reveals, okay, we're kind of living in a simulated universe? And the only thing I could really indicate on my end was that I've had, I guess, feelings of deja vu every so often. I'll dream something and then weirdly, every so often in the near future, it will actually come true. But personally, I've kind of always ascribed it to my subconscious and mind being able to perceive things as opposed to something, paranormal or living in a false reality. Still, those are interesting things for me to say, okay, something's kind of up. What about for you? I mean, have you had any personal moments outside of that, like, immersive virtual reality experience?
Yeah, I have. And it's interesting that you bring up this idea of what are called precognitive dreams, because I often have that experience where I will have a dream of something. And this happened to me the first time back in the 90s. I was doing my first startup, and we were working with IBM, and we had created this product. And, we'd worked with them for many years, and we had a competitor, but the competitor disappeared like, I don't know, 6 months or a year earlier. And so I hadn't thought of it. And one day I had a dream about this particular competitor. And I got up and I said, that's weird. I haven't thought about this guy or this company in forever. And just as I got to the office that morning, I got a call from IBM saying, oh, you know what happened to your competitor? We bought him, and they're building a product now, and that product is going to crush your product. So I just wanted to let you know before we announced it because you're a partner of ours. I was like, gee, thanks that you're going to crush us. But on the other hand, I started to wonder what the heck was really going on here for me to have this dream out of the blue. And I talk a little bit about it in my first book, Zen Entrepreneurship and Treasure Hunt, which is all about these moments of deja vu.
Do you think, like, the simulation hypothesis or even the simulation multiverse ascribes to the Occam's razor? Normally the simplest answer is the most likely.
Right. So that's a good point that many people make. But Occam's razor actually says it's the one that relies on the least amount of assumptions. And so, the problem is those assumptions have to fit observed reality. So you would say, according to Occam's razor, quantum mechanics shouldn't exist because it's definitely not the simplest, right? I mean, having something in superposition, having different values for the same thing makes no sense. And so we're struggling with how do we kind of put this together, right, into a simpler explanation that actually makes sense given the observed data. And so, the two most popular interpretations of quantum mechanics have been the Copenhagen interpretation, which is that everything exists as probabilities, and then it gets collapsed. The probability wave gets collapsed down to a single probability. Now, that's completely counterintuitive and against Occam's razor. The other the other explanation that is becoming even more popular now with guys like Sean Carroll at Caltech, et cetera, say is the multiverse idea. And that idea is that the universe actually splits into multiple universes every time there's a quantum decision to be had. So in this case, we have the cat that's alive and dead, and those are two separate universes. And every time a decision is made, cat jumps out of the box, cat doesn't jump out of the box, you end up with multiple universes. Now, that's an even more intuitive
that one makes you
idea.
want, makes your head spin, because like every time a decision is made, a new timeline branches off. But I mean, with every single person
Exactly.
and every single animal, movement, all that stuff. I mean, how can that, it's hard to even comprehend.
Right. And that's where, turns out the simulation idea may be the simplest explanation for both of those. Much simpler than either of those, which is that we don't know of anything in nature. So the reason that some other scientists don't like the multiverse idea is that it's not parsimonious. You have to create all these universes every instant. And we don't know anything in nature that you can clone, like a large object, right? You can clone maybe cells or information, but you can't clone large objects. Well, it turns out you can clone information very easily. And so if each of the multiverses is an information-based multiverse that says, if this set of bits was this way, that's one universe. If it was this way, it's another universe. And then that gets rendered into like a video game. It just turns out to make a lot more sense. And so even the probability idea in the Copenhagen interpretation is one that most people don't like. Even Einstein has the famous quote that God does not play dice with the universe, right? But when you think about dice and probability, what does probability mean? Like the first time that was defined had to do, I forget some French scientist, I think, or mathematician, and he was saying that if you have a dice, what are the probable or possible futures? So the probability was a measurement that if you roll the dice 6 times, right? How many times will you get this? How many times will you get that? But it was predicated on the idea that you have to roll it multiple times. Otherwise, the probability is kind of meaningless. If you only do it once, chances of 1 in 6 it doesn't really mean anything. And so anyway, that's kind of what led me down this idea that perhaps the answer is staring at us all along, which is that the multiverse describes possible timelines, each of which can be run multiple times. And the probability wave also describes possible timelines. And at any given time, it looks to us as if we're only in one of those. But in fact, all of the information for all of those is present all the time. And so that's what led me down the whole multiverse idea as well.
What features would have to be in place for this to even really be possible?
And, a lot of my work intersects between science fiction, science, and philosophy and metaphysics, just because these are very big questions. And if you've seen The Matrix, the original movie, Morpheus tells Neo and asks him, what is real? Right? And this is right after the scene where he takes the famous red pill. And he says, what is real? It's a series of electrical signals that is being sent into your brain. And so the way I approached it originally was not kind of at this high level, but at the level of, will we be able to create brain-computer interfaces that will basically fool us into thinking that we are inside something like the Matrix. And, when the Matrix came out, it was considered pure science fiction. And in the last 20 years or so, there have been a couple of developments. One is that video games have gotten more and more realistic. Another development is there was a philosophy professor at Oxford named Nick Bostrom, and he came up with what's called the simulation argument. And basically he said that if you have a technological civilization, it either gets to this point where it can create ultra-realistic simulations or it destroys itself beforehand. And so he has a couple of different possibilities within those, but basically it boils down to those two. And, with the possibility that if you learn how to create them, you may decide never to create any. But he said most likely if a civilization ever gets to that point, it will create lots of simulations, which means you can create billions of simulated worlds with trillions of beings in them. And then he came up with the what he calls the simulation argument, which is that if there are trillions of beings inside these billions of simulated worlds, and you are in a world and you are a being, are you more likely to be a physical being in a physical world? Remember, there's only one of those. Or are you more likely to be a simulated world being in these billions of worlds? And there's so many of those. So statistically speaking, his argument was we are more likely to be in a simulation than not, as long as, and this was his big caveat, as long as some civilization ever gets to what I call the simulation point, and my own estimate is that we'll be there within another few decades, maybe 100 years at the most, which in cosmic time is not that long. So that's where philosophy and Bostrom's simulation argument overlaps with my own thinking about technology and where we are going.
So, I mean, you agree with Bostrom that pretty much, I mean, I think he said it was like a 1 in 3 chance that that we currently are living in a simulation.
Yeah, so he said that basically there's 3 possibilities. 1, civilization destroys itself before it gets to the simulation point. 2, it gets to the simulation point and doesn't make any simulations. Or 3, we are most likely in a simulation, right? And so I actually place it as even higher than Bostrom does, because if you just look at his three options, you're at what, like 30%. I actually think it's more likely than not that we are in a simulation and not in base reality. Now, I don't go as far as Elon Musk, who says the chances are 1 in billions that we're in base reality,
Yeah.
right? Which is basically a certainty that we must be in a simulation. It's partly for the reasons that I talked about, but it's also because there are other aspects of consciousness and mysteries in the universe that don't necessarily make sense. It turns out all the religions, whether it's the Eastern religions of Hinduism and Buddhism, or the Judeo-Christian traditions, Islam, Christianity, and Judaism, they're all telling us that the world around us, the physical world, isn't the real world. And, in the Eastern traditions, they are much more explicit. They call it Maya. It's an illusion. You go in, you play a character, you end, you go out, you come back, and something gets preserved during that time, right? And where is that something stored? It's somewhere else, somewhere outside of physical reality. Now, of course, these are all metaphors, right? In those days, they used the metaphors of the Leela, the stage play. They use metaphors of a dream, that you're inside a dream, but you don't know it while you're in it because you're deceived. In the Western traditions, there's the Book of Life. And in the Islamic traditions, there's the Scroll of Deeds, which is a list of everything you've done. And of course, these metaphors all came up, a few thousand years ago. If you were to do the same today and say that somebody is recording every little thing you do, and you're going to have to look at it afterwards, we wouldn't say it's the Scroll of Deeds, it's Judgment Day. We'd say we're recording this entire video game, and then you can stream it over Twitch, and you can replay it, which is what people who have had near-death experiences tell us as well, is that they've had to relive every single instance in their life, which means it would have had to have been recorded somewhere, right? If you can relive it like that, where? In a cloud server somewhere. And so, the simulation hypothesis is a way to use our current understanding of technology and virtual worlds and identity to basically bridge these 2 gaps between science and religion, with all of this other unexplained phenomenon that's out there. And so that's another reason why I think, that it's more likely we're in a simulation than not.
Did you see Devs by any chance on Hulu?
Yes, I did.
Okay, yeah, I thought that was a really thought-provoking one because, they kind of put in some parameters on how it, such a thing could take place, and I thought it was a really good way of like showing that idea. But I think it also kind of touched on another idea at the end, by the end of it, is that in some ways I think that here's kind of why I think simulated realities and multiverse is a little problematic, is because if it does ever get to that point, those simulated realities also kind of get to a point of simulating other realities. So in some ways, it's also kind of a turtles all the way down problem.
And a lot of people, talk about this, like, and what led me down this path was this idea that we could create our own simulation. Oh, crap, we may already be in a simulation, right? Which would be kind of a stacked simulation type of scenario. But so there's another science fiction film that I think is worth mentioning when we talked about stacked simulations, and that came out in the same year as The Matrix in 1999. It was called The 13th Floor. And I don't know if you've seen that, but it takes place in the 90s, and they're building a virtual reality of what Bostrom would call an ancestor simulation back in like the 1930s. And so they go into that, and they live in that world in the 30s, and then they come out, and but turns out they themselves are in a simulation from the future, and someone from, let's say, 2041 comes in and tells them that they were running thousands of simulations, and only one of those got to that point where they could create their own nested simulation, and that's why they were shutting the simulation down. And so, I think it brings up very big questions of what is the purpose of the simulation? How much computing power is there? What type of computers are we talking about? I mean, with quantum computers, you get almost an infinite amount of computing power in a sense, because you can basically explore every single path simultaneously. And now Deutsch says that's because we're essentially going in different uniparallel universes where each of those values exist, and in an instant we're finding the answers we want, and then we're somehow figuring out which of those paths we wanted to be on using quantum interference. So there's lots of different complications that come up related to computing power, et cetera, but it all is based on assumptions of what kind of computers. And I think we don't know what kind of computers a simulation that was running us might be on. Most likely it's not going to be, my MacBook Air, right, is not going to be the type of computer on which you could run the type of simulation that we're in. But give it, 100, 200, 300 years, and perhaps we will have those computers as well.
I loved how you used all these movies, and you're like, at the beginning, you're like, oh, did you see 13th Floor? And I remember, reading in the book, and I was like, oh, I haven't seen this one. And then you just completely ruined the movie for me in the ending, and you never gave me some damn spoiler alert. So at least, that would be my biggest bone to pick, to say, hey, spoiler alert coming, that's my biggest issue of contention at the moment, at least for the book.
I guess if your readers are going to get the simulated multiverse and you're going to see the summaries of movies, I mean, that one's 20 years old, right? So
that one I could somehow skipped. And so then when I saw another movie that came up, and I was like, oh, damn it, I can't read what this one's about, because then he's going to ruin it for me on this one.
In the new book, I tie it back to Philip K. Dick's ideas. He gave a speech in Metz, France in 1977 that's become famous because of a quote where he said, "We are living in a computer-programmed reality, and the only clue we have is when some variable is changed and some alteration occurs in our reality." And so, I went back and reread that speech because I had interviewed his wife, Tessa, who makes a great interview guest, by the way. So about, his beliefs on simulation theory, because the Wachowskis who created The Matrix had been inspired by Philip K. Dick. And she said that he actually believed that we were running multiple timelines, and that little variables would change and sometimes big variables would change, and then they'd rerun the timeline. And oftentimes we would have this sense of deja vu, or something is different or wrong. I mean, he actually believed that The Man in the High Castle, right, which is the recent series from Amazon based on his book from 1960, like a long time ago, where the Japanese and the Germans won World War II. He came to believe that that was an actual alternate timeline that ran. And then for whatever reason, it wasn't an optimal timeline, and so you rewound, and then the timeline ran again, and that some people have memories from these others, and that's what the experience of deja vu is. And so he said, we would have the sense, deja vu, that we were saying the same things or hearing the same things again. And so, that's looking at this whole area of consciousness. And I also talk about something called the Mandela effect. And Philip K. Dick said in 1977, all you would have to do is find a group of people who remember something a little bit differently from the main timeline, right? From the consensus gentium reality is, or the, the currently actualized timeline. And so, he was using different terms back then, but looking at it today from the point of view of quantum computing and being able to run and change variables, the whole thing kind of fit together to me. And it was actually a colleague of mine from Google who I was talking to in Mountain View, California, and he had read my book about the simulation hypothesis, and he said, well, you should really look at the Mandela effect. Because the simulation hypothesis is the best explanation for it. And I thought it was just a case of a bunch of people remembering things wrong, right? Faulty memory. And it may still be.
Bad news.
It's a very... What's that?
Bad news stations. Faulty news reporting.
Yeah, all the faulty news reporting, that could be it. Some people think it has to do with parallel universes. Some people think it has something to do with CERN. So you got all these different theories out there about where these memories might be coming from. And I said, well, what if we just said, okay, maybe all these people aren't crazy. Let's assume that at least some of the big events they remember might have actually happened. Let's do a big what if experiment, right? Could this actually happen? And it turns out that, what we think of as time in quantum mechanics is not what we think of as time in everyday reality. And so, this new book is kind of a what if exploration using ideas of quantum mechanics, quantum computing, um, and simulation theory and video games, in a way to see if we could explain this idea in a way that made sense, rationally, and could be a model for what I call the simulated multiverse.
Yeah, it's like kind of funny when I was first like writing that deja vu question, and I talked about how my subconscious mind could perceive things. What my brain actually first put was compute. That was actually the first word. Like my brain can compute things instead of perceive. So, but I didn't want to say it like that because I don't want to give you the satisfaction of it as I'm playing devil's advocate here a little bit. But I want to I want to trail back to also how that relates to Philip K. Dick and your interactions with his wife and his widow. I believe in the book you mentioned how his widow talked about how Philip K. Dick actually believed he had conversations with the people who are running the society, right? With like, the programmer, or so to speak.
Yeah, so I think that for him it started with a kind of a little experience where he was sure there was a light switch in the bathroom, and he went in and there was a chain. You remember those old chains they used to have on lights sometimes, or maybe it was the other way around, but it was different from what he was sure he had, you know, he had switched the light hundreds of times. And so he began to wonder if there were these little changes. And that's what led him to write his story, The Adjustment Team, which was the basis for the Adjustment Bureau, which has stars Matt Damon and Emily Blunt. And then it was from that he began to get weirder memories of alternate realities where America was a police state. And that's, what he wrote, The Man in the High Castle, and a couple of his other books based on that. But yeah, so she said that at some point he saw some entities which were kind of like blobs of light, and some of his later works gets into that. And so, we're talking about what would be considered metaphysical experiences here, right? But he had some kind of communication with these strange beings that were represented in some blob of light that were telling him that they were messing with the timeline, and that. Another example they gave him was the assassination of JFK in Dallas. Said they changed it, but he ended up getting assassinated somewhere else, or in Orlando, or some other place. And so what this whole thing reminded me of was how we do simulations. Like, how do we run simulations on computers? We run multiple scenarios. We change the variables, and then we say, what is the most likely outcome, like as in the weather? What is the most optimal outcome? For example, that's how we train video game AI. Like that with AlphaGo, or even going back, to perhaps simpler AI with the chess playing computers that beat Kasparov way back in the 90s, Deep Blue, I think it was. But the way they work is, they will try different scenarios and they'll run those, and then they'll condition and figure out what is best. And so he came up with this theory that someone or something, a programmer, was like playing chess in a way with these different realities. And so it all kind of tied together with this idea of computation and what we call self-play. Like, how can a AI learn to play the game of Go, which is very complicated? Well, it plays a million games against itself. How can a car learn to drive? Well, you put it into a simulated environment where it can do all of these different things, and it can learn from that environment. And that kind of reminded me back to what even the ancient religions have been telling us, that we're here to learn and to make certain choices. It's almost like it's been set up for our benefit to go through these different experiences. And so that's kind of what led me to writing this book, The Simulated Multiverse.
So like, what happens when there's like an error in the technology? I mean, what happens when the character dies? Does it even matter?
Well, there are different types of errors and glitches, right? Personally, I believe that we each have an element of our own rendering devices, in the same way that if we were both playing, Fortnite, you would be rendering it on your iPad and I would be rendering it on my iPad, which allows for this phenomenon that I was talking about earlier, which is rendering things slightly differently. And so that's one type of glitch in the Matrix. Another, in the movie, The Matrix, they showed the cat going by the door and then going by again. So the glitch was a replay. of the same item. Philip K. Dick talked about this idea of the feelings of deja vu in the sense that you've gone through this before, not almost as a glitch, but almost as a feature. Like that's what it's supposed to do. It's supposed to run you through these scenarios again and again to try out different scenarios. Now, I think this gets to the heart of what I like to call the RPG version or the NPC version of the simulation. In the NPC version, which stands for non-player characters, everyone is just AI within the simulation. And then, if your character dies, your code is there. The information may still be there, but that's really it for your character, at least during that run. But in the RPG version, it's more like a video game. It's more like the Matrix, where we exist outside of the game, and yet we are inhabiting or playing avatars within the game. So in that case, what happens when your avatar dies? You wake up, right? And that is the metaphor that many of the Eastern traditions and religions have been using, for thousands of years, is that you wake up from the delusion or the dream, as they called it. And even Shakespeare used the metaphor of a stage play, right? All the world's a stage and the men and women are merely players. I like to think that if any of those guys were around today, they would use the metaphor of a video game. Not, that would be the up-to-date metaphor to describe what's happening.
I mean, kind of in some ways, it's dangerous to look at the world like a video game or a computer simulation. I mean, people have killed other people based on them not thinking that it mattered because reality wasn't real. I mean, how do you reconcile that between those two?
Yeah, and I think what you're referring to is like the Matrix, the so-called Matrix defense, right? Mm-hmm. Where there was a guy who shot his parents, and I think he ended up actually not using that as his actual defense in that case. But it turns out people have been murdering each other for a very long time, here, and as I said, I think simulation theory is actually very consistent with what the religions have been telling us. And within simulations and video games, you have achievements and quests. And what happens if you don't achieve it? Well, you have to keep working on it, and you have to do it again and again. So, I think you can look at it either way. On the one hand, you can say, well, all your actions are being recorded, and that's your score in the game, right? And so if you're murdering people, you're going to get a negative score, and you're just going to have to come back and do it again. Sorry. So is that really something you want to do? Which is more akin to what at least some of the religions have been telling us, is that the reason we're being recorded is so that we can evaluate our performance. And so, yeah, you're free to do things that are really bad. And that's true in a physical world, although you would say in a physical world, it doesn't really matter that much either. If you don't, if people just show up once and they're gone, and you're going to be gone soon too. So what do your actions matter? So I think you can use those arguments either way, in either a more materialistic or a more spiritualistic. But the spiritual traditions have used that same argument as a way to get people to behave better. And so, I tend to use a blend of the two by saying that whenever we have difficulties in our life, which we all have, that gives you a better perspective on that, because you can say, well, it's a quest or it's an achievement that I signed up for. Right. And therefore, it's a difficulty that I'll just have to deal with for now. And that's my quest, which may be different from your quest or somebody else's difficulty level in the game itself.
Riz, give out your website and or social media if you have any before I let you out of here.
Sure. So you can follow me on Twitter at Riz Stanford, or you can go to my website, which is zenentrepreneur.com, which is named after my very first book, which was called Zen Entrepreneurship.
I appreciate it. Rizwan Virk, Simulated Multiverse Simulation Hypothesis. Get those two books. Really appreciate your time. I guess if we can even really use that term anymore, right?
That's right. Time isn't what we think it is. Thanks so much for having me on.
My absolute pleasure. We'll have to have it on, I guess, for the third one, the simulation threequel, whatever it may be.
I haven't come up with a title for that one yet.
Well, you can hold on to that one for a little bit. But no, I really do appreciate your time. Thanks so much.
Yeah, thank you.
Like I said before, my brain really stops and digests some of this information. It is probably going to explode. So, one, I'll let the information wash over me again at another time. In the meantime, let me distract you with telling you about what's going on for the rest of the year. And hard to believe that there's only 2 more episodes left to do so. For those shows, I'm going to do something a little bit different. I'm going to switch up the format. Instead of talking with another person, a guest, an interview, it's going to be me and only me. And those two episodes are actually going to be wildly different from each other. On the next one, this one has really been a long time coming because I have collected a lot of information about the death of Martin Luther King Jr. and it's gonna make you rethink what the history books have told you about who is really responsible for his assassination. So please come around for the next one. Until then, be well and let well be. I'm DJ BJ Turnoff signing off for the Mind's Eye.